nuclear fission first. So it's a process of splitting of heavy nucleus into a two nuclei of roughly equal mass. So let's say we have uranium. Okay, we have a uranium, and we shoot it with neutrons. Okay, we do not shoot it with protons because the nucleus carry positive charge, and the proton also carry positive charge. If you shoot it with protons, then the proton will be repelled away, pushed away, so it won't go into the nucleus. But if you shoot it with neutrons, then this nucleus will absorb the neutrons. Okay, so we shoot it with neutrons. When this neutron absorbed by the nucleus, then the nucleus becomes very unstable. Remember, the stabilities of nucleus depends on the number of protons and neutrons. Okay, so if you suddenly add one neutron into the nucleus become very unstable. When it becomes very unstable, okay, so it will be broken. Okay, it will be broken into two smaller pieces. And usually at the same time, some neutrons will be released as well. Okay, so we shoot one neutron, is broken into two, these kryptons and barium, and at the same time, three neutrons is released. Okay, so you see, the nucleus is broken is not because of the impact of this neutron. It's not this neutron because it hit it and break it. No. The fission occur is because after the nucleus absorbs the neutron, it becomes very, very unstable. Okay? And very, very unstable, and itself is broken into smaller pieces. Okay. Now during this fissions, okay, is broken. Some mass defect occurs. Okay, there's some mass loss, and the mass loss is released as nuclear energy, heat energy, and a kinetic energy. Okay, the kinetic energy is the energy possessed by these neutrons. Now, nuclear fission seldom occurs spontaneously. That means it does not happen by itself. Usually, it happens because there are some neutrons. Okay, neutrons shoot into the nucleus, make it to become unstable. Then only it occurs. Examples of nuclear fission. You don't need to memorize this. Okay, you don't need to memorize this. Uranium shoot by neutrons. Okay, is broken into a barium and kryptons, and at the same time releasing three neutrons and energy. Or uranium shoot with neutrons. You see here, both also shoot by neutron, but the outcomes may be different. Okay, not necessarily you shoot by one neutron then you get the same thing. No. Okay. After this, it becomes a xenon and a strontium, and at the same time, two neutrons is released. So these are examples of nuclear fissions. You don't need to memorize this formula. Okay, it involves some calculations. Okay, but if they want you to do the calculation, they will give you the equations. Okay, so don't need to memorize the formula, the equations. In the nuclear reactions, the mass difference in the reaction is 1.5 times 10 to the power of negative 8 kg. Find the heat release in these reactions. Okay. Again, they want you to find the nuclear energy. So nuclear energy, we use E equal to mc square. Okay. Again, the C must be given. Okay. C is equal to 3.0 times 10 to the power of 8. Okay. This one is easy because they straight away give you the mass in kg. So 1.5 times 10 to the power of negative 8 kg multiplied by 3 times 10 to the power of 8 square. Okay, 1.35 times 10 to the power of 9 joule. So you can see that this is 1.35 billion joule. Okay, just with a small amount of mass defect. Okay, this is less than 1 gram. Instead, this is how many gram? This is equal to 0.00015 gram. Just small amounts of mass defect can produce a large amount of heat energy. This is 1.35 0.0000000 joule. Okay, 1.35 billion joule. So that's how we calculate the amount of energy released. If you get a very big number, okay, the amount of energy is a billion joule. Okay, don't be shocked. Okay, that might be correct. Okay, yeah, because it's just small amount of this mass defects can produce large amount of energy. Example 4, and they want you to find the mass defect in this case. Okay, so the answer is 9.11 times 10 to the power of -4 kg. Okay, chain reactions. Chain reactions. Now you see, just now we learned that when a uranium absorbs a neutrons, then it becomes very unstable, and then it's split. It's split into two new atoms. Okay, two new atoms. And at the same time, 3 neutrons is released. 3 neutrons is released. Now, when this 3 neutrons is released, these 3 neutrons, okay, first, okay, the possibilities. First is it hit nothing, okay, because there's nothing here. There's no uranium here. Okay, it hit nothing, so nothing happens. Okay, or it hit another uranium, but the energy of this neutron is too low, so it does not cause the uraniums to split, to be broken. Okay, it becomes not stable, but it's not broken. It's not broken. Okay, so nothing occurs. Okay, or if the energies of the neutron is high enough, it hit another uranium. This uranium undergoes another fission. Okay, it's broken into two new atoms. Okay, and at the same time this neutron is released, and these neutrons hit another uranium. Okay, then it's broken again. Yep, and then this one's broken again, release neutron, and then it will hit another new uranium. Okay, and this happens again and again and again. Okay, so we call this process. Okay, this one break this. Okay, this one break this. This one break this. Okay, we call this process the chain reactions. Okay, means that it's just not one reaction. It's a series of reactions occurs again. So this is called a chain reactions. So a chain reaction is a continuing process of splittings of the nucleus in which the neutrons that are released from the breakings of a nucleus initiate another similar nuclear fissions. This occurs because after we split the nucleus, new neutron will be released. Okay, but chain reaction, there's a requirement because you see some of the neutron may hit nothing. Okay, if you don't have enough uranium there, okay, so then let's say these three neutrons okay, does not hit any uranium, then the reaction will stop there. Okay, so it means that if you want the chain reactions to occur, you must have enough uranium. Okay, you must have enough uranium, and the minimum mass for the chain reactions to occur is called the critical mass. So the mass of fission material must exceed a certain minimal mass, that is called the critical mass. Less than critical mass, no chain reactions occurs. Just the reaction just occurs for one or two times, then you stop already. Okay, no chain reactions occurs. So the mass must exceed certain amount. That's called the critical mass. So if the material is less than this value, too many neutrons escape without hitting the nuclei, then preventing a chain reaction from happening.